Morning.
Morning, sir.
Can you see my screen?
Yes, we can.
Okay. So, in today's lesson, you can see my screen.
Yes, we can.
My name is Dominic Mwangi, and I'll be a trainer taking you through introduction to OOPs and OOP concept, and I'll go direct to this activity. So, at the end of the lesson, I expect you to be able to define what is OOP, object-oriented programming, and you give examples of OOP languages. So I'll go direct and I'll define what is of OOP. OOP in bracket object-oriented programming is a programming paradigm that treats data as an object which has both data and method in bracket functions associated with it. This means that object can be manipulated as units and the data and method associated with them can be reused. Now, I want to ask a simple question. What are examples of OOP languages? Class?
Yeah,
Yeah.
yeah, Java,
Yes?
you have Java, you have Python,
Yes?
C++, you have C, JavaScript, PHP, Ruby, Swift na Kotlin.
That's nice try. Thank you. Thank you for your contribution. Ngeno? Yes. Java, Python, C++, C Sharp, JavaScript, PHP, Ruby, Swift, Kotlin, all those are examples of object-oriented programming. Now, uh, why do we need to? Why do we need OOP concepts? I want one of you to take us through that slide that asks the question: why do we need OOP concepts in? Let's be interactive.
Okay, let me take you through that. Why do we need OOP concept? Object-oriented programming and system. OOP's concepts in it helps reduce code complexity and enables the reusability of code. Programmers feel like working with the real-life entities or objects. Object-oriented programming is a programming paradigm that brings together data and methods in a single entity called object. This promotes greater understanding as well as flexibility and maintenance of code over a long period of time.
Thank you for your contribution. That's true. Actually, the reason why we need the OOP concept is because they enable code reusability. They help programmers to work with real-life entities or objects. The OOP concepts also promote greater understanding as well as flexibility and maintenance of a code. That's very nice. Now let's go now to the real now to the concepts themselves. Now the first concept is objects and classes. Objects are the basic unit of OOP or object-oriented programming, representing real-life entities. They invoke with the help of methods. These methods are declared within a class. A class is a predefined or user-defined template from which objects are created. It represents properties, methods that are common to all objects of the same class. It has several features such as access, modifiers, class names, interfaces, and class bodies. We have the next concept, which is abstraction. I need one of you to take us through abstraction. Abstraction, sorry.
Abstraction. Abstraction means showing only the relevant details to the end user and hiding the irrelevant features that serve as a distraction. For example, during an ATM operation, we only answer a series of questions to process the transaction without any knowledge about what happened in the background between the bank and the ATM.
Yes, thank you, Eric, for that your contribution. This is true. Okay, using this example, abstraction simply means that it it enables hiding of irrelevant information or information that is not relevant to the user. And for this, using this example of an ATM machine, the operations basically needs the user does not has not doesn't need to know what is going inside the bank. Only the required data is needed for him or her to be able to perform a transaction. The third concept is encapsulation. Encapsulation is a means of binding data variables and methods together in a class. Only object of the class can then be allowed to access these entities. This is known as data hiding and helps in institution of data. Any question? Any question? Okay, let's proceed. We have now we go to the fourth concept. I need one of you also to take us through inheritance. Quick, fast. Anyone?
Inheritance is the process by which the class inherits the functions and properties of another class. The main function of inheritance is the reusability of code. Each subclass only has to define its features. The rest of the features can be derived directly from the parent class. We have the types of inheritance. We have single inheritance, refers to a parent-child relationship where a child class extends the parent class features. We have the multi-level inheritance, refers to a parent-child relationship where a child class extends another child's class. Hierarchical inheritance, this refers to a parent-child relationship where several child classes extend one class. And we have finally the multiple inheritance, refers to a parent-child relationship where one child class is extending from two or more parent classes. Thank you.
Thank you very much for your contribution. Now we go to the final concept, which is polymorphism. Polymorphism, it is the ability of an object to take on many forms. Now we have different types of polymorphism. The first one, it is we have static polymorphism, and the second one, dynamic polymorphism. Now, what is static polymorphism. Static polymorphism is implemented using method overloading. Method overloading is when a class has multiple methods with the same name but different parameters. For example, the math class has two methods named square root in bracket. One method takes a double as a parameter and the other method takes an integer as a parameter. The next type of polymorphism is dynamic polymorphism. Dynamic polymorphism is implemented using method overriding. I want to get the difference. We have the first one was it is implemented using method overloading, and for the dynamic polymorphism, it is implemented using method overriding. Method overriding is when a subclass defines a method with the same name, signature, and return type as a method in its superclass. For example, the dog class overrides the speak function method from the animal class. Uh, Now, before we end, okay, this marks the end of the class. But before we conclude, I want us we have a recap of whatever we have learned today, very quickly. Anyone?
We have learned about the key concepts, basically the components of OP. One is abstraction, whereby it's the hiding of the internal implementation of an entity, but only displaying what the user needs to see. We have also learned about objects and classes, whereby the class is the one which acts as a blueprint for the creation of the entities. That is basically the object. So it is from the class whereby we get the objects. Then we have polymorphism, we have encapsulation. Yeah, basically that's what I've learned today.
Okay, thank you for your contribution. Yes, so for today's lesson, we are just looking at the concept of OOP, or object-oriented programming, which are 5. So on your own time, on your own free time, just go and find more and try to be conversant with those concepts so that you can prepare for your next exams. Now, before I end, I have assignment for you, and you'll write this assignment. Also, I'll send it through the class rep. Describe 5 trends in OOP in the current industry. Describe 5 trends in OOP. Basically, just write, describe 5 trends in OOP. I repeat, describe 5 trends in object-oriented programming. That is 20 marks. This work should be submitted in our next class. Thank you very much for your time, and we can call it a day. Have a good morning.
Thank
Thank you
you.
so
Thank you.
much.
You're welcome. Unafinya. Nifinye.